Your MongoDB query is slow, but that doesn't always mean the query is badly written. Sometimes the query is fine. MongoDB just doesn't have the right index to help it. Let's take a simple payments collection. Inside it, we have fields like currency, status, amount, and paid at. Now, let's build the query visually. First, I'll add currency and set it to USD. Then, I'll add status and set it to paid. Next, I'll add the amount condition, greater than 1,000. And finally, I'll sort by paid at descending, so the newest payments appear first. The next step is to run the query. We can see that the query returns results, so technically it works. But when we check the explain plan, we can see the real problem. MongoDB is doing a collection scan. It scanned 297 documents and returned only 3. In a small demo collection, that still feels fast, but in a real collection with thousands or millions of payments, this becomes a performance problem. VisuaLeaf shows only 1% efficiency and recommends creating an index. The recommendation already includes the main filter fields, currency, status, and amount. If you don't want to read the full explain plan manually, you can also use AI Explain. It gives a quick summary of what is happening. Here, it tells us the query is scanning the collection, and that an index would help. Now I'll create the index from the index manager without writing the command manually. But because my query also sorts by paid at, I'll include paid at in the compound index too. That way, the index follows the full query pattern, not only the filters. Currency and status are exact filters. Paid at helps with the sorting. The amount supports the range condition. So the idea is not just to create any index. The idea is to create the right compound index for this specific query. After that, I'll run the same query again and check the explain plan one more time. The difference is clear. Before, MongoDB scanned 297 documents and returned only 3. After creating the compound index, it examines only 3 documents and returns the same 3 results. This time, the explain plan shows IXSCAN, which means MongoDB is using the index instead of scanning the whole collection. So the query result did not change. What changed is the amount of work MongoDB had to do. This works when I test one query manually, but in a real database, I also need to find slow queries that happened over time. So I'll open the query profiler here. VisuaLeaf shows the slow operations from the Learning Platform database. In the Slow Queries tab, I can see that the Payments query used COLLSCAN. And if I scroll down, I can also see slow queries from other collections, not just this one. From the Actions column, I can open more details for each query. VisuaLeaf shows the generated query code, the explain plan, execution statistics, and server information. So I don't have to search manually through logs just to understand what happened. And in index recommendations, VisuaLeaf suggests a compound index for that repeated query pattern. This one also includes paid at, because the query sorts by payment date. So the index follows the ESR idea, equality, sort, range. And that's the workflow I want. Find the slow query, create the right compound index, and test it again with explain. So VisuaLeaf helps you fix MongoDB performance problems faster. You can build the query visually, check the explain plan, find slow operations in the profiler, and create or manage indexes from one place. Same result, less work for MongoDB. You can try it with your own MongoDB queries by downloading VisuaLeaf.